Hearty welcome to all knowledge seekers to my channel. This is Dr. Madhusudan Rao Kadapa. In this video, I am going to explain the theory of arithmetic progression and some solved problems. Now coming to the definition of arithmetic progression. So in general, we come across sequences formed according to some procedure like adding some fixed value or multiplying with some fixed value or adding by some successive values which increase or decrease in a particular sequence. But when a sequence is formed by adding a fixed value to the preceding terms, in such case it is called an arithmetic progression. In arithmetic progression, the difference between any two successive terms is constant or is called common. Hence the difference is called common difference and it is denoted by the letter D. Mathematically, the common difference D is equal to Tn minus Tn minus 1. That means the difference of succeeding term minus preceding term. Now let us look at the general form of arithmetic progression. Here the first term of an arithmetic progression is denoted by A and the common difference is D. Then the second term T2 is equal to A plus D. We are adding the common difference D to the first term A to get the second term, or we can write A plus D as A plus 2 minus 1 into D, because the coefficient of D is 1. We can write it as 2 minus 1. So it is A plus 2 minus 1 into D. In the same way, the third term of AP becomes A plus D plus another D, A plus 2D, which may be written as A plus 3 minus 1 into D. And so on. If we keep on writing the terms like this, the nth term will become A plus n minus 1 into D. So this is the general form for the nth term of an AP. So the arithmetic progression will in general be like this: the first term A, comma, the second term is A plus D, comma, the third term is A plus 2D, and so on. The nth term is A plus n minus 1 into D. Now sum of n terms in AP. Suppose we have an arithmetic progression like A plus D, A plus 2D, and so on, A plus n minus 1 into D. Then sum of n terms is given by Sn equal to A plus A plus D plus A plus 2D plus and so on. A plus n minus 2 into D, this is the term before the last term, plus, and the last term is A plus n minus 1 into D. This is first equation. Now let us rewrite the terms in reverse order like this. So we can write Sn equal to A plus n minus 1 into D, which is the last term in first equation, plus A plus n minus 2 into D, plus and so on, plus A plus D and A at the end. So this is second equation. So the second equation is just the reversal of the first equation. Now adding the two equations, we get 2 into Sn equal to, here add A to A plus n minus 1 into D, that is the first term A in equation 1 to the first term of second equation A plus n minus 1 into D, we get 2A plus n minus 1 into D. In the same way, the second term is A plus D in first equation, and in second equation it is A plus n minus 2 into D. So here 1D gets cancelled, so we get again 2A plus n minus 1 into D. In the same way, till the last term, if we add the corresponding terms, we get every time 2a plus n minus 1 into d, since we have n terms in the series, we get 2a plus n minus 1 into d n times. So we can write 2 into Sn equal to n into 2a plus n minus 1 into d, or otherwise it is Sn equal to n by 2 into 2a plus n minus 1 into d. Now the same equation or the expression for sum of n terms in AP may be represented in another way, provided the first term, last term and number of terms in a arithmetic progression are known. Then we can write Sn equal to n by 2 into that 2a may be split into a plus n minus 1 into d. Then n by 2 into a is the first term plus a plus n minus 1 into d is the last term, that is nth term. So here we have n by 2 into a plus l means a is the first term and l is the last term. So this one multiplied by n by 2. Now let us have some problems on arithmetic progression like this. First one, if a comma a minus 2 and 3a are in arithmetic progression, then what is a? Here we have three terms a minus 2 and 3a. Then the property of arithmetic progression is that the difference between any two successive terms is same, that is common. So if you take the common difference d equal to a minus 2 minus a, that is second term minus first term, and that is also equal to third term minus second term. So on simplification, what we get, on left hand side we have minus 2 minus a plus a gets cancelled, is equal to 3a minus a is 2a plus 2. So on simplification we get a equal to minus 2, so the answer is B. Next, what is the next number in the arithmetic progression? 2, 5, 8 and so on. So just by observation we can easily say that the common difference is 3. 2 and 5 differ by 3, 5 and 8 also differ by 3. So the next term should also differ by 3. So 8 plus 3 it is 11. Now here we can write this like first term a equal to 2 and common difference d equal to 5 minus 2 is 3. So the fourth term, that is the next term, is 8 plus 3 which is equal to 11. So the answer is C. Next, the 16th term of AP 3, 5, 7, 9 and so on is how much? Now we have first term a equal to 3 and common difference d equal to 2. Then the 16th term of AP is a plus 15d. So 3 plus 15 into 2, that is 30. 30 plus 3, 33. So the answer is A. Now which term of AP 2, 7, 12, 17 and so on is 87? Here the first term is a equal to 2 and the common difference is 5. Then we don't know which term will be 87, so let it be nth term. Then the nth term of AP is given by a plus n minus 1 into d, which is equal to 87. Now substituting for a and d, so a is 2 and d is 5. So on simplification we get n equal to 18. That means the 18th term of that arithmetic progression is 87. So the answer is D. Next, how many 3-digit numbers are divisible by 6? Now 3-digit numbers start from 100 and end by 999. Now of these numbers, the first 3-digit number which is divisible by 6 is 102, and the last 3-digit number divisible by 6 is 996. So the common difference between such sequence is 6. First term is a equal to 102 and common difference d is 106, and the last term is, that is nth term is 996. So we have to find out n. Now a plus n minus 1 into d is 996. So substituting for a and d, we get n equal to 150. So there will be 150 such terms which are divisible by 6. Answer is B. The first term of an arithmetic progression is 6 and its common difference is 5. Then what is the 11th term? So first term a equal to 6 and d equal to 5. So 11th term will be a plus 10d. So a is 6 plus 10 into 5, 50, 56. So the answer is D. And how many numbers between 200 and 600 are divisible by 4, 5 and 6? Here if you observe the multiples of 4, 5 and 6, they are not common. So we have to take LCM. So LCM for 4, 5 and 6 is 60, and the first term which is divisible by 60 between 200 and 600 is 240. And here since we are not including 600, so the last term will be 540, which is divisible by 60. So first term is 240 and the last term is 540. Then common difference D is 60, the LCM. By simplification we get n equal to 6. So the answer is B. If the fourth term of AP is 14 and 12th term is 70, what is the first term? So fourth term may be written as a plus 3d. So a plus 3d is 14, and the 12th term is a plus 11d, which is equal to 70. On simplification we get 8d equal to 56 or d equal to 7. On substitution we get a equal to minus 7. So the answer is C. Next, 1 plus 2 plus 3 plus and so on, 98 plus 99 plus 100 plus 99 plus 98 plus and so on plus 3 plus 2 plus 1. Here if you observe, we have the numbers from 1 to 100 and then in the reverse order from 99 to 1. So it is the sum of first 100 numbers, but 100 is only once. All other numbers are repeated twice. So we have to find out the sum of n numbers in arithmetic progression, where a equal to 1, the first term, and common difference d is also equal to 1. On simplification we get it is Sn equal to 5050. So 1 plus 2 plus and so on plus 100, up to 100 it is 5050. For the next series, that is 99 plus 98 plus and so on plus 3 plus 2 plus 1, also be the same, but 100 is missing in that. So we can take the sum as 2 into 5050 minus 100, which is equal to 10,000. So the answer is D. The sum of first 20 odd natural numbers is, now the first odd natural number is 1, A, and the odd numbers differ by 2. So the common difference is D equal to 2, and number of terms is 20. So n equal to 20. On substitution in the expression Sn equal to n by 2 into 2a plus n minus 1 into D, and simplifying we get Sn equal to 400. That means the sum of first 20 odd natural numbers is 400. So the answer is C. So thanks for watching this video. For more videos on arithmetic and reasoning, like, share and subscribe my channel. Thank you.